Operations on functions is what this new chapter starts off with. All right. The good news of this lesson is, for the most part, it's old stuff. Okay? There's very, very little new things here. Okay? Very few new concepts, new ideas. Not a lot that's really new. Okay? A lot of it is old stuff that you already know how to do. The problem with it, and then where the new stuff comes up, is getting to the old stuff that you know how to do. Okay, so that's kind of where the issues lie. So before we move from this slide, that's function notation, right? Everybody seen that before, right? F of x, and typically it follows up with like something about like, I don't know, 2x plus 1 or something like that, right? Ever seen that before? Okay, that's what function notation is. Now, whenever another type of problem you used to see, and then what you used to do with that, before I move on to that, the second part, is you would do like f of 3, right? And you do 2 times 3 plus 1, which gives you 6, plus 1, which gives you 7, right? Okay? Yeah, we did something exactly like this. And then what we also did, and, well, I'm just coming up with all kinds of ideas. This we kind of bring this back Monday, okay? We don't really do a whole lot with this up today. But a second type of problem that we would do is, instead of just having it as f of x equals 2x plus 1, we would take away the f of x, and we'd have the 2x plus 1 plus 3x minus 6, right? Or maybe it was 2x plus 1 minus parentheses 3x minus 6. Or maybe it was 2x plus 1 in parentheses with parentheses next to 3x minus 6, right? One of those three maybe. We've seen all three of those kind before, right? Okay. All you do here is combine like terms, right? 5x minus 5. Down here you distribute the negative through, then combine like terms. Okay, so negative x plus 7. Down here you what? Multiply, which is also known as, with this one? Oh, F1.
Foil.
The FOIL. Good, since it's two binomials, right? Okay, so all of those is stuff that you've seen before, you know how to do, and you definitely know how to FOIL. All right? So in that part, it's not new stuff. The new stuff is here. Okay? And specifically, here in these definitions. All right? Here in the definitions. So basically what we're doing today is, instead of giving you the problems right away, all right, whether they're combined like terms or FOIL or multiplying a binomial times a trinomial, instead of giving them to you right away, they're going to go about it in this manner, where they, if you look at the examples, they give you two functions. F of x is 2x, g of x is negative x plus 5, and then they tell you what to do with them. Add them, subtract them, multiply them, divide them. So as you can see, you're taking those two. Add them, subtract them, multiply them, divide them. Okay? Obviously, dividing is new to us. We'll get there when we get there. All right? So once you get to the example column, everything kind of makes sense, right? It's just 2x plus negative x plus 5, combined like terms, x plus 5. Okay? Big whoop. I know how to do that. Know how for years. Distribute the negative through on the subtraction, makes it 3x minus 5. Distribute the 2x through, 2x squared plus 10x. Okay? Nothing new there. That's old stuff. The new stuff is getting there. The new stuff is in this definition box right here, okay, the way it's notated. Okay, that's the new stuff. Now, we wrote down earlier f of x, right? We said we all seen this before, right? Okay. Now, the new part here is f plus g of x. That's how you say this guy right here. F plus g of x. F minus g of x. F times g of x. F divided by g of x. That's how you say those four. Okay? That's how you say them. And here's the tough part. All right? And here's where the new stuff is. This left-hand side is what the book likes to give you, what the ACT likes to give you, what the worksheet generator likes to give you. Okay? Because in technical speaking terms, this is your proper notation. This left-hand side. This right-hand side is what makes the most sense on how to go about these problems. Okay, so what you need to train your eye to do is to see your left and move it to, and change it to the right. Okay? Because you will be given the left-hand side as far as what you do, but you're better off changing it to the right-hand side to actually go do it in. Okay?
Are they the same thing?
They are, yes, but here's what will happen. I'll show you what will happen on the next one, okay? Or I'll probably show you right here. Now, here's my point, okay? Let's look at this example here. Let's just focus on just the addition, okay? Just the addition. Up here, they say let f of x equals 2x and g of x equals negative x plus 5, okay? So without knowing how to do the problem, without doing the right side, okay? I want everybody looking at the left, okay? Now, what do you think you do? See, if we have f plus g, wouldn't it mean just take f, which is what? 2x, and then plus g, which is negative x plus 5, right? Okay. So that takes care of this part. Then what do we do with this x here? Anybody? Or at least what do you think we do? Yeah, that's the bad part. See? That's the bad part. See, everybody wants to put that x right here, out here. Okay? But do this inside. What's 2x minus x? That's just x, and then x plus 5. See, that's what's already up here. Not x squared plus 5x. Okay? That's the hard part. This x right here in this column is for notation purposes only. Okay? It's kind of like a display case. Or display purposes only. Okay? Kind of like the toilets at the Lowe's, right? They're not there for functional purposes. They're there just for you to look at, right? Okay? It's the same thing.
That's for really Lowe's like that?
Yes.
But you didn't go to Home Depot and see like the clothes inside.
Okay? These are for display purposes only. This x does not get used. Okay? Just like you don't use this x here whenever you had it, right? We never use this x. We always just use what it was equal to. Okay? Make sense? So your biggest hurdle for this is to understand that notation going from here to the right. And that goes for all of these. Okay? So does that make sense to... Hold on. Does that make sense to everybody? Okay, and we'll get to a couple of these. Once you get down to it, these aren't too bad. Okay, as far as the actual work of the problems go. Okay? Everybody good? Now, like we said, addition, subtraction, multiplication, you guys should be good with, pretty good with overall. It's just like terms, multiplying, that kind of stuff. The only weird one that we haven't really done a whole lot with ever with anything to this point besides a little bit is division. Okay? And what you're going to find out today is the division in this section isn't a whole lot like when we did synthetic division last semester. Okay? Sorry, Jocelyn. Alright? It's actually almost nothing like that division. It's actually easier. Okay? It's easier than synthetic division, to be honest. Okay? The only hard part about division is remembering this little tidbit right here. Okay? Right there. G of x cannot equal 0. If you ignored that, you need to make sure you put that part down, because that part's super important. Okay? So if you missed that part, get that down. G of x cannot equal 0. Everybody's favorite question. Why? Why can g of x not equal 0? Berg.
Isn't it because they're supposed to be like in the form of g of x?
Not quite, no. Mr. Taylor.
Because make everything equal 0.
You're closer, but not. It wouldn't make everything be 0. And what can you do, Cozy? What can't you do? You can't divide by 0, right? If you've made the g of x is in the denominator in this example. Everybody see that? Oh, where's my finger at? There we go. Okay? G of x is in the denominator in this example. Okay? And we can't divide by 0, which means g of x can't be 0. Okay?
So we should highlight that.
Yes, I would. Okay, logic makes sense there? Okay, divide by 0, therefore that function can end up being 0. Okay? And we'll get to the part where that changes for our problems as we go, because we're going to have to start talking more and more about 2 words from your past. Okay, but we'll do that on the next, not this coming slide, but the one after. Okay, so you can also see these given a couple different ways. We're going to talk about that throughout the day too. First problem, given f of x equals x squared minus 4 and g of x equals 2x plus 1, find each function. And then it'll be these words. Indicate any restrictions in the domain or range. All right. Indicate any restrictions in the domain or range. That whole section has to do only with division. Okay? That whole entire section only has to do with division. If you're not dividing, it doesn't matter. Okay? If you're not dividing, it's irrelevant. Okay? For this one, we're not dividing, so we don't care. Okay? So the first one we have f plus g of x. Like I said, first thing I would do is change that from the notation they give you to this notation right there. Okay. I would do that. Alrighty. Now, f of x in this case is what?
X squared.
X squared minus 4. Good. X squared minus 4. I put a plus, and I always put my second function in parentheses. G of x in this case is what? 2x plus 1. Good. And then add them up, which means combine your like terms. Okay, so we look at it, x squared, there's no more x squareds down the line. When we look at it, we see the 2x all by its lonesome, so no more 2x's or x terms. We have the negative 4 plus 1, so negative 4 plus 1 is negative 3, and that's your answer. Alright, next one, subtraction. Same thing to start with, at least. I always switch it from that form, so f of x minus g of x. Okay, so f of x, once again, x squared minus 4 minus, and I always put my second in parentheses for this reason especially. So g of x is still 2x plus 1, but what do I have to do next? Distribute that negative sign. Good, okay? Because if you don't distribute that negative and you don't put the parentheses specifically, you're just subtracting the 2x, you're leaving the plus 1. That's not good because you need to subtract all parts off of g of x. Okay? So you need to make sure you put g of x in parentheses after this subtraction, distribute that minus through. So we get x squared minus 4 minus 2x minus 1. Mm-hmm. And then once you got that, you go through and combine your like terms. So we have x squared minus 2x, and we got like terms with the negative 4 and the negative 1. Have minus 5 right there. Just so I can make a point about how, it's going to go back to old problem, but typically you won't get any bigger than trinomial times binomial. That's why I wanted to go with this, because I don't feel like you guys need any help with foiling, because I feel like that's your strong suit. Binomial times trinomial might need a little help there, so that's why this is here. So this one we have f of x equals x squared plus 7x plus 12, and g of x equals 3x minus 4. Find each function. Indicate restrictions on the domain or range. Once again, that second part there is for division only. Okay, so f times g of x. And even when I'm doing these problems by myself, because that's what I do at home for fun, I even write it out, f of x, like that. in parentheses, kind of, hold on, times g of x, so I don't mess it up, and put that extra factor of x in there, okay? Rewrite it like that, so that way you aren't off by a factor of x, okay? So f of x in this case is x squared plus 7x plus 12 times g of x, which is 3x, minus 4. Okay, so we're multiplying a trinomial times a binomial. Okay, we've done this before, we did last semester. Okay, we need to take the x squared that's first and multiply it to the 3x and the negative 4. Which gives you 3x cubed minus 4x squared. Once you do that, we go to the what? The next one, good, the 7x, and do the same thing. 7x to the 3x, 7x to the negative 4. So 21x squared minus 28x. And then we go to 12 and do it again. So 12 times 3x, 36x, minus 12 times 4, 48. Okay? Your multiplications are going to give you your obviously give you your longest, ugliest, not nice, I mean it's a nice answer, but, yeah, that's your next step, yeah. Okay? But it's not, they're going to be longer answers, you know. Okay, since you are typically going to do tries time buys, so it's going to be long. Yeah, and then you go through one more time, combine like terms. All right, so we got the 3x cubed all by its lonesome, so he doesn't have anybody, so he just comes on down. We got the minus 4x squared and plus 21x squared, 17x squared, minus 28x and plus 36x, plus 8x, minus 48. And that's your answer. Okay. Do what? Okay. Everybody good? Okay. So those three are problems you've seen before, done before. It's just getting to them, right? Okay. Nothing new, nothing crazy. Okay. Now your division one. I started off the same way. I split that x up. F of x divided by g of x, like that. Okay? I started like that. Now, you'll also start it the exact same way that we started the rest of them, and that means you plug in your functions for their respective letters. So f of x is x squared plus 7x plus 12 divided by g of x, that is 3x minus 4. And that's half of the battle right there. Okay? That's actually all you really do with the division part itself. Now, the only bad part is division has two parts. Okay? Division has the part where you actually put one over top of the other. That's what we just did. What's division's second part, you think? Hmm? Mm-mm. Mm-mm. Mm-mm.
Wait, wouldn't we subtract the exponents like how you said?
Nope. Not allowed. It's underlined.
Combine like terms.
Underlined.
Oh, indicate any restrictions in the domain.
There we go. Just any restrictions in the domain or the range, okay? That's what we got to do now, okay? So, 2 words from your past. What is your range? Range is your... Nope. Not in this case. Good. Y, okay? Ranges are your Y's, domain are your X's, good. I was trying to trip someone up and make them say X's for range, and I'd go, ha ha. Okay? Domain is your X's, range are your Y's. Now, your range, to be quite honest, you're not going to mess with. Okay? We're only worried about the domain restriction. And that domain restriction is where you are growing up in Algebra 2. Okay? Because as we move deeper into this course, you know, the weather starts turning nice again, and we can all start going outside and being out past 7 o'clock. That time of year, okay, you know. We're going to start talking more and more about the domain and range of these functions, okay? What x's can we and can we not put into the functions? What y's will we or will we not get out of them? That's later. Right now, we're only worried about one thing. We are worried about the number that's going to make that denominator turn to 0. Okay?
That's what I was going to ask you.
That's the only thing we're worried about, is what number in the world makes that denominator become 0. Now, you got two ways to do it. Way 1 is going to sound like a really smart aleck answer. Okay? So here it is. Way 1 is this. You look at it and you figure it out. Because sometimes these will be that easy. Okay? Like the one, if you look at the very first example where it was like a negative x plus 5, well, duh, it's 5. Because negative 5 plus 5 is 0. Okay? So some of these you'll be able to look at and go, well, duh, there it is. Okay? Some of them may be a little harder. Maybe like this one, 3x minus 4. Okay? So here's way 2. You take that denominator. Okay? Okay? The denominator is 3x minus 4, and it cannot be what? Cannot be 0. Okay, watch this. Equals means can, right? 3x minus 4 can equal 0. Equals with the slash through it means cannot. Right? All right? After that, solve for x. Add 4 over. So 3x now cannot equal 4. Divide by 3. So x cannot equal 4/3. Okay? And both parts, both the division itself and your restriction are your answers. Okay? You circle both parts. All right, at least you need to write this down.
But we didn't divide them.
I know. That's my point. You don't have to. You just need to write one on top of the other. For this problem, this part of the year, that's good enough. Okay, so let's start going through these so we can get this done. Let's do f plus g. So now, like I said, you're better off switching the notation, but if you can do it without messing it up, you don't have to, okay? So as long as you get in the habit of, for like plus, you just do 2x plus 10. Whoops. Plus the g of x, which is x squared plus 10x plus 21. See, here's the magic of the app. I can just move them over. Hey, there we go. All right. I know. Okay, so you don't have to write that step where you make it f of x plus g of x as long as you don't put this x down here with it. Okay? That's my big worry. As long as you leave this x up here and know that signifies your notation for functions, and you just do 2x plus 10 plus all that, then you don't need to write it. Okay, makes sense? So we go through, we got your like terms. We got x squared. All right, we got 10x and 2x, it looks like, to give us 12x. 10 and 21 to give us 31. Okay, and there's addition.
Wait, Mr. Moore,
Yes, sir.
when you had like with the 3 and
All right, now do the subtraction same way, but make sure you in the subtraction one we put what? Minus and then?
x squared.
Parentheses, good. Okay. X squared plus 10x plus 21. Distribute that negative next step. Okay. So 2x plus 10 minus x squared minus 10x minus 21. Get you like terms. So once again, x squared's all by its lonesome. We have the 2x and the negative 10x. Give you negative 8x plus 10 minus 21, negative 11. Okay. All right, f times g. This one's going to be a little rough. 2x plus 10, foiled out with x squared, bless you, plus 10x plus 21. Oh boy, here we go. 2x goes to all three. So we get 2x to the third plus 20x squared. It's 42x. And then we take the 10 to all three. So 10 times x squared is 10x squared. 10 times 10x is 100x. 10 times 21 is 210. You guys did a good job picking numbers. Okay? Yes. Go through, get your like terms. So we have cubed, 2x cubed. I think that's the only one we got of it, right? Okay. We got 20x squared and 10x squared to give you 30x squared. $42x and 100x to give us 142x. Man, you guys are gutsy with these numbers. And we have to bring along that 210. Woo! Okay? But y'all did it. Alrighty. Last one, the division. Okay, and this is where I said I might have a little bit of a trick up my sleeve, because I still have sleeves, so I have tricks. Equals, easy part, 2x plus 10 over x squared plus 10x plus 21. It's the easy part. Now you have to figure out what numbers makes that denominator be 0, correct? So we need to take that denominator. And we need to set it not equal to x squared plus 10x plus 21 does not equal 0. What type of equation is that? It is a trinomial. Okay, it's got 3 terms, but not what I'm asking for. Okay, it's got a name, special name. It starts with a Q. Quadratic. Good. Okay, it's a quadratic equation. Now, we've learned in the past a couple different ways to solve quadratic equations. One of them is how? It's y'all's favorite thing. Starts on F. The other one. Factoring. Good. Okay. Factoring is one way. If you want to do that, that's fine. What's the other way? This will be for the juniors. What's the other way we learned? Starts with a Q. Quadratic what? Quadratic formula. Good. And if I recall correctly, you have a program for the quadratic formula, yes? Yeah. So use it. So use it. Okay? Use it. Put it in your calculator. Okay? Do your quad formula. Put in 1 for A, 10 for B, 21 for C. Alright? It's going to tell you the discriminant is of that, I don't know. But then once you do it, it's going to tell you the solutions are what? 2 numbers. -7, -3. Those are the 2 numbers that it can't equal. Right there. So there's two numbers this time. Okay. See what I did there? See what was up here? Huh? Now you gotta do the bottom. No matter how nasty it might look, you want to do the bottom because that's what can't be 0. Okay, Mr. LaFleur. Homework's page 318, 4 to 11. Okay, 318, 4 through 11. Lesson check on Monday.